Our question says that we have a mass of iron that is 290 grams or 0.290 kilograms at a temperature of the iron, which I call T sub I, of 180 degrees Celsius. And it's placed in a 95-gram aluminum calorimeter cup. So M sub A for aluminum is 0.095 kilograms. And then it contains glycerin, M sub G, of 0.250 kilograms. And both of those have a temperature of 10 degrees Celsius. The final temperature in equilibrium, is 38 degrees Celsius, and it wants us to find the specific heat constant of glycerin. So in order to do that, we're going to consider the fact that the heat lost by the iron must be equal to the heat gained by the aluminum and the glycerin in equilibrium. So M sub I times C sub I, which is the heat lost by the iron, is the iron temperature minus the temperature in equilibrium. And this must be equal to the heat gained by the glycerin and aluminum. So this is going to be the mass of the aluminum times the specific heat constant of the aluminum times the temperature in equilibrium minus the temperature of the aluminum initially, plus mass of the glycerin times the specific heat constant of the glycerin, which is what we're trying to find, times temperature in equilibrium minus initial temperature of the glycerin. Okay, solving this equation for the specific heat of the glycerin, we find that this is equal to, actually, let's go ahead and do this on the next page so we have enough room, is equal to what we have originally on the left side of the equation, which was Mi Ci times the drop in temperature of iron, so T equilibrium, T iron minus T equilibrium, because it's the drop in temperature of the iron, and then minus part of what we had on the right side of the equation. We're going to have MaCa times the temperature gained by the aluminum, which is equilibrium temperature minus initial aluminum temperature. And then all of this is going to be divided by what was multiplied by, this should be C sub G. That's what we're solving for. So all of this is going to be divided by what was originally multiplied by C sub G, right, to get C sub G by itself, which is equal to, or what C sub G was multiplied by was the mass of G, M sub G, multiplied by the temperature gain of the glycerin. Temperature in equilibrium minus original temperature of the glycerin. So plugging all these values into this expression, we find that this comes out to equal 2,305. And of course, the units for specific heat are joules per kilogram times degrees Celsius. We can box that in as our solution to the question.